Welcome. In this video I'm going to show you how you can work with the binomial distribution with Microsoft Excel. The formula for the binomial distribution is actually shown here. The part before the big weird looking E is actually the binomial distribution itself, but usually we're interested in the cumulative density function, so then we're summing up over a particular range. Now this n over I is actually a binomial coefficient, which is n factorial divided over k factorial times n minus k factorial. And factorial simply means to keep on reducing it with one integer and then multiplying the results. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1. Now Excel has actually a function for each of these. The first one is the binomial dot dist, and then you enter the k value, the sample size, the number of trials, the probability of success on each trial, and if you want the density function, the cumulative one, you add true for cumulative and false if you just want to know the particular probability for that particular k value. The binomial coefficient, this one is also available in Excel with combine, number of combinations, and the factorial as well. So if we have, for example, 10 trials and we want to know the probability of success for having exactly 4 or less successes, and the probability of success on each trial is 0.2, I could just simply use the binomial distribution function, binom dist, and then select the number of number s, which is actually my k value, then select the number of trials, which was 10, and then the probability of success, which is this one. Now cumulative is either true or false. I want it cumulative because I want the probability of having 4 or less successes, and apparently that's 0.96721. We could actually check if this is correct by going over the formulas ourselves. The binomial coefficient, so 0 to 4, because I wanted to know 4 or less, that includes 0. The binomial coefficient is the number of trials, the n, as you can see. But actually it's that one factorial, so I need to first say factorial, and then the n, and then divided over, open up a set of parentheses, another factorial, and then say k, which is this one. I'm going to press actually F4 because when I copy paste this down, I want this cell reference to K9 to stay the same, and the same goes for F8. F4 simply places dollar signs around it, which means that if I copy paste this function now down, or this formula, it will not change that K9 value. Multiplied by, oh, it's actually not k, sorry, it's going to be the I, so in this case it's going to be this one. And then multiplied with the factorial of n, and that n does need to be fixed, so F4 again, minus k, which in this case is actually I, and there we have it. And I can now just copy paste, or can use the autofill handle to drag it down, and here we have our binomial coefficients for these particular k values, or in this case I labeled them I. I could have simply used that combine function, so let's see if that actually gives the same result. The number is 10, so that's the number of trials actually, and then the number chosen is this one, and I can copy paste this down, and hopefully that gives the same results. Right. If we now look at the formula, so we've done this part, so now we need the p to the power of I, so that's going to be simply the p value, which is over there, F4 again, because I'm going to copy paste this down, to the power of, and then this one. Now I can copy paste this down, and it should be showing, so it takes this one, and this one stays the same. Alright, so that takes care of the p to the power of I. Then this whole bit, which looks more scary than it actually is, it's just following it along, 1 minus that p over there, F4, and then to the power of n, which was over here, F4 minus the I, which is over here. And then close all of that. Copy paste this down. And now we actually have all of these three. So we simply need to multiply them together. So that's this one times that one times that one. So I could use probably the product function if I'm not mistaken, but since there are only three, I'll just do a simple multiplication. These three can multiply with each other. Copy paste this down, and we now have our binomial distribution up to k is 4 with p of 0.2. Now this weird looking e means to simply sum them all up, so I can do a sum function or alt equals, and that gives me the sum, and that should give us that 0.96721, and indeed it matches. So that's how you can work a little bit with the binomial distribution using Microsoft Excel. Hope this was helpful, and thank you for watching.